as we're looking at the first law of thermodynamics and many other functions that we're going to be looking at in thermodynamics, we need to discuss the idea of a state function. And U, the internal energy, is our first example of a state function. And what a state function is it's something that depends only on the state of the system. So it's a property that only depends on the state. What I mean by the state is, what are its, what state is it in? The state of a system. So if we're thinking about, say, a gas inside of a piston or something, the state would be defined by what's the pressure, what's the volume, what's the temperature. We'll just put molar volume, what's the density. So that would define the state of the gas, and the internal energy only depends on those things. And so if you move from, say, one state, P1, V bar 1, T1, to a second state, P2, V bar 2, T2, we change the state of the system. It doesn't matter how we get from the state 1 to state 2. The change in energy will be the same regardless. It doesn't depend. We would say it's path independent. I gotta spell that right. Independent. So it doesn't matter how you go from state 1 to state 2. And so, delta U will just be given by what's the difference in the internal energy at state 2 versus state 1. So if we want to, think about, say we have, we're thinking about a differential change in U. If we want to integrate this from 1 to 2, we would just take U2 minus U1, right? That would just tell us what the difference in the internal energy is. Now, some examples of things that are not state functions are things like work and heat. And you may remember we had this form of the first law of thermodynamics that I wrote earlier in a previous video. And these are written with different D notation here. So the D here indicates that we have a state function. It doesn't matter how we go. So this is what we call an exact differential. Because it doesn't matter how we go from state 1 to state 2. Whereas these for Q and W are inexact differentials. It matters how the process happens, what the heat and work change are going to be for a system. So let's look at an example of why work maybe wouldn't be the same depending on the process. So if we have, say, a constant pressure and we do a compression, and we can calculate the heat from this, the work from this. Say we go from V equals 1 liter to V equals 0.5 liters, and that the external pressure, the internal pressure starts at 2 bar. All right. Oh, that doesn't particularly matter because our work is going to be minus P external times delta V. So we know delta V, and let's imagine that we have two different situations where we have different external pressures. So if P external is equal to, say, 4 bar, we do need to know that the external pressure has to be larger than the internal pressure to be able to actually compress it. But let's say it's 4 bar, then we can calculate W equals minus 4 bar times 0.5 liters. So that's the change in volume. Oh, and that's a negative 0.5 liters. So we'll get a positive, because we're compressing the gas, increasing internal energy. We get 2 liter bars, which is the same. A liter bar is the same thing as 100 joules. So this is 200 joules. But if we do the same process, but the external pressure was higher, if we were pushing with more force, 8 bar, we would plug this in and see we're going to get a different value. Right, and we'll get 4 liter bars, which is equal to positive 400 joules. So the amount of work that's done on the system is different when we have a different process that happens. The change in U, the delta U value, will be the same for both of these processes because our initial state and our final state are the same. The gas went from 1 liter to 0.5 liters. There'll be a change in pressure. The internal pressure will increase, but it'll be the same amount. So delta U would be the same. Q would not be the same, right? Just like work, the heat would not be the same either. And so just to follow up again, coming back here to these dq and dw, if we write dw and we say we want to integrate from 1 to 2, it doesn't make any sense. We can't say w2 minus w1. There is no such thing as w2 and w1 like there is for delta u over here, right? So this is not a proper way to think about it. It's just, if we integrate it, it's just going to be w, and it depends how we went from state 2 to state 1 to state 2, what the actual value of w is going to be.